Good afternoon to everybody. This is my first conference in India. I moved to Germany 14 years ago and settled down there. This is my first conference. I would like to thanks for the invitation. Mr. Garg already mentioned about the renewable energy submission in Germany. For example, 30% is energy is coming from renewable energy. It is true, and I have to share some my personal experience with that. 8 years ago, I was paying like a 23 cents per unit for my house, and now I am paying like 31 cents. So I just give the decision that the audience can make it, I do believe that the coal gonna be a dominant resource for the energy for Asia and also the developing countries as well. My company is a ZEMAG slagging gasification technology. It is basically 180 years old company. This company also contributed the technology to the German economic development in terms of coal briquetting, coal upgradings, and so on. There are two businesses we are doing right now. One is the coal upgrading technology, for example, coal drying and coal briquetting, so that you can increase the heating value of the coal. Usually in Germany, we have like a high moisture content lignite coal. It is not possible to, transport high moisture content coal because it is consumes so much money. You are simply wasting like 50 or 60% of money to transfer the water. So ZEMAG developed this technology in order to handle this coal. For example, dry the coal and then briquette it. And in like 160 years till 1980, in Europe, most of the house heatings, they were using the coal briquettes. The ZEMAG were expertised. Since 1980, the European, German economy, they thought that coal is, not a green source of energy, so they imported the gas from Europe, from Russia, for example, and they used the heating for purpose through gas. But there are still some briquetting plants are running in Germany, and sometimes I call it as a museum because it is 60 years, very old plant, and still it is running successfully. Second one is like a slagging gasification technology. Just now, our panel chairman, Mr. Garg, mentioned that slagging gasification is huge investment and very less return of investment and so on. But recent developments in China, this shows that it is economically feasible. I will come to that point later. So these are the typical process for the briquetting. So just a coal drying, coal crush the coal and then screening and also dry the coal. Let's say from moisture content from 60 to 10 or 12%. And then do the briquetting. And this briquettes, you can use it for the gasification and also for the coking process, for example. So we do have some two technologies, and these days when you go to the conference or to the company mesa or something, they always say that there is a one technology is existing, only just a roller press. It is unfortunate. It is true that raw extrusion press was developed only by ZEMAG. The last machine we supplied was like 30 years ago because of higher the OPEX and so on. But you get a guarantee that you can, end of the day, you can produce the briquettes. That is the beauty about this raw extrusion press. And the last few years, we invested some manpower to improve these technologies. And right now, we are looking for the partner to build this pilot scale demonstration plant in India or also in Indonesia or in Australia as well. So we are looking for the partner. If there is interesting customers, then they can contact us. These are some of the reference plants that ZEMAG built it for the past 150 years. As you see, the last biggest briquetting plant built was 1971 or 1980. It is simply because that gas market came, and you see the trend changes from the coal to gas in European market. And we also constantly working with the TU Freiburg. It's a university. They are experienced with the brown coal briquetting and brown coal processes. For example, the constant innovations and also developing the technologies as well. Second technologies is a gasification. This is BGL. We transferred this technology in 2010 from British Gas Logi. Mr. Green is here. He worked also in this technology, as he mentioned. The first reference plant was in Germany. It was in Schwarzepumpe. They had a huge this gasification complex, not only with the Logi gasifier, BGL, and also entrain flow gasifiers and so on. The plant was in operation till 2007, and after that, the German government, they thought that, okay, it is cheaper to import the gas from Russia, for example, for $2 per BTU or something. So if we have a gasification plant, then production cost may be $5 to $6. So they thought that it's economically not viable. They shut down the plant in 2007. And ZEMAG bought this technology in 2010. Our management thought that China is the biggest market for gasification, and it is true. Since then, we are able to build 3 biggest plants in gasification in China. This is the transfer of ownership from the GL to the ZEMAG. So we do own all the database, what all the research they have done, and what all the results and so on, and design manuals, and also experience reports as well, and also the simulation. So what we do is, like, we take the coal analysis, and then we do the simulations, and be able to come up with whether it is feasible to go for the high-scale projects or not. And we also provide the service as well. It's a fixed bed slag gasification. It is the top part is pretty much same like Logi, and bottom part is similar to the slagging gasification parts. So there is no environmental pollution in this, zero water pollutions in this. So because you have a high temperature range in the gasifications, up to 2000 degrees Celsius in the combustion section. The flexibility in the gasification is high. You can see some high efficiency, low oxygen consumptions when compared to other technologies, and high carbon conversions, and moderate outlet temperatures. So that you don't have to invest a huge in design part when it comes to the downstream units. It is possible to use this technology for SNG and coal to chemicals and fuel applications as well. The feedstock flexibility, we can use this PGL technology for different kind of coals, variety of coals, and also the plastic waste and wood and so on. This waste materials already used in Schwarzepumpe in Germany, and then they produced methanol in this plant, and it was successful. So right now we don't have a reference plan for using this waste material gasification, but it is the future for the BGL technology. Feedstock flexibility in terms of when Indian coal, when you consider the ash content is 35-45% more ash content we have seen. We do also got a recommendation from the EIL people that coal washing unit, after that coal washing, when you have a medium range coal, then it is possible technically, and also economically it is feasible to do the gasification for the coal to chemicals. And also if we have a coal fines, it is possible to do the briquette and do the gasifications as well. And some of the applications, so if we have one gasifier, you can put downstream units to produce different kind of applications, for example, SNG, chemicals, and power generations, and so on. Some of the reference plant, there are 2 reference plants, New Coal and also in China Coal, and all our 3 plants are in China. As you know, the investment is huge, and China is investing huge in coal-based chemical industries. They're both the reference plant. What we have is producing fertilizers from coal to fertilizers, ammonia, urea. And one first plant, they are producing 500,000 tons per year ammonia and 800,000 tons per urea. They are using the lignite coal, 3 gasifiers. It is successfully operating for the past 4 years. The moisture content they are using is 30 to 37%. Ash content is 13 to 20%. China Coal is the biggest successful for the BGL or the ZEMAG slugging gasification technology. They are using sub-intermediate coal, high quality coal. They are producing up to 1.7 million tons of urea. And this plant is running since 2014 successfully, and we did a lot of optimizations and also improved a lot of in terms of design. Because in the olden days, that BGL technology, there were no numerical techniques or advanced technologies available to optimize the design. But in the past 3 years, we did intensive work in simulations, for example, safety, and also the finite element methods to optimize the design and also the process as well. This is all the aerial view of the China Coal plant. And we do also have to do the simulations and also the real plant value data. And as you see that CO2 and CH4, all the components are pretty much predicted from the gasification, from the simulations, which we have seen in the reality as well. Yes, okay. And for ZEMAG slugging gasifications, that is the new generation from the BGL technology, which has adaptability to include the coal fines as well. Not only the lump coal as we've seen in the Logi gasifier, but also it is possible to use the fine coals as well in the gasification. And also tar yield devolatilization gasification. For example, if you have a downstream process like a dusty tar problems, then you can put this dusty tar back to the gasifier and produce the effective gas more. This is so in this 2 ways possible. One way is to do the briquettes and then put it in the gasifier, or we can use the pulverized coal and then directly inject it to the gasifier. So you have that operating flexibility and also same times the feedstock flexibility as well. And these are some of the technical information that lump coal and also the pulverized coal where you are injecting and so on. Just I move on with this straight quickly. And with this new technology like a ZEMAG slugging gasifications, this is the new plant, LMTT. It is also in China. They are using lump coal and also the fine coals as well. And this plant is producing 300,000 tons per year methanol. And this plant is using like a high ash content coal, which is similar to Indian coal. We have tested it last year, and there is no problem with the technology to handle this coal. But when it comes to economic feasibility, it doesn't make sense to use the high ash content coal and then gasify it, because end of the day you are not making any profit out of it. So you are investing huge and also not getting enough money out of it. So our recommendation for the Indian coal gasification developments, it does make sense to go with let's say up to 30% of ash content coal, and gasify it. These are some of the design and also commissioning the data. We provide the license and also the technical service as well, and also some proprietary equipments and so on. I do want to mention that Mr. Garg mentioned about the economic feasibility of that gasification technology. It is true. It is a huge investment, and due to the volatility of the feedstock and also the offtake, the product, the volatility, it is difficult for the private investor to go for this huge investment. We have seen it in China especially, that most of the coal-based chemicals industries are invested by the state-owned companies, and they see the demand and they invested it. And for example, I share some technical, the financial information about the one plant. It's called China Coal, and they are producing 1.7 million tons of urea. And their production cost, including the financial depreciations, all the other aspects, it's $140 per ton of urea. So now the market price is $190 or $200 per ton of urea, but still able to make money out of it. And also from the byproduct as well, they are making a lot of money. So economically, it is feasible. But in the beginning, that when it comes to the investment, then somebody has to take a risk and then move on. Definitely, in the future, then they will make a good profit out of it. Yes, there are technologies available for the, for example, energy mix. When we talk about this solar, wind, and also coal-based industries as well, it is our choice to make for future. I would like to thank you very much for your time, and thanks.